Thank you very much for the invitation and for such a nice introduction. And well, to satisfy your need, your request, I'm a laureate of the PTI competition. I'm a winner of the PTI competition. I have had the chance of presenting that presentation in front of the Deputy Prime Minister in NASK, headquarters. And I will present a concept of a biometric system of over-the-air signature that I had the pleasure of working on for my engineer's thesis, supervised by Wojciech Wodo. So, I'm still a student at the Wrocław University of Science and Technology in cybersecurity. I work at NASK as machine learning specialist, and I also deal with behavioral biometrics there. My interests, I like IT forensics or digital forensics or capture the flag competitions from cybersecurity. So, let me start from handwriting analysis methods. So the first features that we can get from a signature are static features. So, for example, based on Barack Obama's signature sample, we can check the angles, for example, the execution of some elements, the interruptions in the signature, and how is the distribution of the signature process, and also dynamic features are interesting because here we are also adding time in it. So we can verify how much did it take to create particular fragments of this signature. And in the system that I will present to you in a moment, we used both types of features, both dynamic and static. So what was our goal to create this piece? We wanted to use devices that we wear on an everyday basis, or we use laptops, smartphones and cameras that they are equipped with. The goal was to show you that, to prove that there is a space for developing an original solution that can support digital verification of a signature. So as part of my work, we have built this system, started an experiment to show the best parameters of the system, and we created a useful database of signatures because the system was tested also for real users as well. Moving on to the main topic. What is over-the-air signature? Well, it's a digital signature, and it is a broad definition here, as digital signature may include all the signatures that can be digitized, and it's an example of behavioral biometrics, as I said. Example features: improved hygiene, no need for a stylus or a tablet. If the system is implemented in an office, you don't need that. And more space for making the signature, so you are not limited by a small screen. The only thing that limits you is the camera of your device. Disadvantages? We also have disadvantages here. Our experiment showed that some people had to perform a couple of those signatures, so this was a longer learning time, but it depended on a person. In extreme case, it ended in 30 minutes, but these were like 2 people, and there were also people that took like 2-3 attempts, and they knew how to create a signature quite comfortably, I would say.
o jeszcze te nasze badania. Wystąpiły też tutaj czynniki
Other
oczywiście bolącej ręki.
aspect included, other disadvantages included hand discomfort. It got painful after a number of a dozen signatures like that. So where can it be used? Well, I would say in quite a lot of places. First, it could be a supplement for digital identification. For example, supporting the online authentication process in banking processes as well. I will return to that in a moment. So, moving on to the project. It was divided into three main stages: signature registration, extraction of features, and classification. Starting from the first one. To register the signature, I used of a ready framework called MediaPipe by Google that allows you to detect your hand using a camera and its distinguishing features. As you can see, red dots are marking these features. Thanks to that, we could have implemented two gestures. First, to the left, with an index finger raised up. That means I will start drawing the signature, and two fingers up means pause. So the moment when you, for example, want to take a break between your name and surname, or put a dot over the eye. This is how the flowchart looks like. So we're starting the program, you activate your camera, then you need to detect your hand, and using these two gestures you direct or operate the software that then can be saved or another sample may be created. I will show you a demo, how it looks like. This is a subsequent attempt, so without touching the screen, and here we have a laptop camera. I'm creating this signature in a given box. This is how our test looked like on real users. The people were supposed to create 15 such signatures. Moving on to the test results. The person who created this 15 signatures had the task of filling out this brief evaluation of the system, taking into account a number of reasons like the ease of use, user comfort, system security. And as you can see, the scores were mostly from 3 to 5. Sometimes there were negative assessments, negative opinions, but since I study cybersecurity, it's interesting to see that system security never got a 1. As a cybersecurity student, I'm particularly proud of that. Second module, feature extraction from signature. And here it gets interesting because this is how it looks like when you draw your signature. We're not verifying the static feature only, but also dynamic features. At the top you have the original signature collected from the software, and here are the points distributed in time on X and Y axis. And this signature, once collected, you need to prepare it for further processing so that a given classifying model knows how to understand it, how to process it further. And here we have 3-4 main stages of preparing that signature. The first one is removing redundant elements. So when somebody was signing and kept their finger in one place for a longer time, then the system registered that. So you remove the excess redundant elements. Then green means applying linear interpolation. So adding points that were omitted in registration of the image because, for example, the screen error, let's say. Then purple is applying normalization. So a given signature is sent to the point so that it makes it is continuous. And then the last step is the signature points are divided into 20 time segments. In this case 20. And each segment, as you can see here, to the left can have the beginning in red. This is the beginning of the drawing A. So each segment would have particular features being assessed. And in here we have selected 5 dynamic and 5 static features. To give you some examples, that can be average speed, the time of signing, and then static features can be total distance between points or angles between the X and Y axis. This is how the model looked like. This is a representation in the form of a table, so for each time segment we have calculated 10 features that I mentioned. And here is the table that shows the mean deviations, and we have collected 15 signatures, as I said, and out of 10 of these signatures we have created profiles, user profiles. So this is an example of a user profile built on 10 signatures they've made. And then the other 5 signatures were used for testing this system, and I will tell you about it in a moment. Here we have a flowchart, how it looked like. Not getting into details, I've discussed the most important aspects. So signature processing, calculating particular features, and then their means and deviations. And moving on to this last segment, signature classification. I will start from 2 basic biometric metrics. So first, false acceptance rate. So the situation where an unauthorized person is trying to log into the system, and that is let in, that would be false acceptance, and then false rejection rate. So the opposite situation. I want to get verified, and the system does not recognize me as me and rejects my entry. And here we also had EER ratio as one of the metrics that says about a place where FAR and FRR have an equal value. Our goal, of course, is to have these values as close to 0 as possible. This is the flowchart of the classification process. Most important here, I would say, is what we have in green. So we take the user's signature as the form of a table, we compare it with their own profile, and we check for the false rejections, and then it is confirmed to compare to with profiles of other users, 56 profiles in this case, and then we check the FAR error. So we have conducted other experiments. I can show you only a fragment of those. Here we checked the impact on the results by removing certain features, here from 1 to 10. So these are the features that I mentioned before. We also checked the distribution into time segments. We selected into 20 time segments because the results were the best here, and the error ratio was like 10%, no more.
zobrazowane wyniki.
Here you have the image of these results. In the description of the drawing you have the thresholds that we've selected based on experiments, and not getting into greater details, the results of the classifier was 10%, EER was 10%, and we also checked ready-made solutions, machine learning models in popular libraries of Python, and here the results got down to 4% of the EER, and the same went for the SVM model, again around 4%. And this is the comparison of all the classifiers we have tested. So custom, KNN and SVM, and as you can see the best result for our classification was 10% and the FAR was 14%. For our system, FRR was 7%, and then using the classical machine learning, these results went down to 3 to 4%, and the entire system accuracy, depending on the classifier, were between 85 to 96%. To summarize, we managed to develop a biometric system consisting of modules for signature registration, feature extraction from signatures, and implement machine learning models. We conducted numerous experiments. A signature database consisted of 859 samples that can be used for further experiments, and the system can be a potential second factor in verifying the signatures digitally because of the EER value would be around 4%. And that's it. Thank you very much for your attention and the possibility of presenting here. Please let me know if you would like to contact me further with some questions or comments.